Hello everyone and welcome to the Victoria Game Engine series. It is episode 10 and today we are going to be creating the Windows GL context. First up, a little bit of explanation of what I mean by an OpenGL context and specifically a Windows GL context. You can think of an OpenGL context like effectively the center of the state machine, so to speak. Every read-write operation that you do within your OpenGL logic code will ultimately require there to be some kind of internal state that's been set up in order for that read-write operation to happen. For us, it's therefore very important that we try to create an OpenGL context that we can then apply to a given window so that we can make sure that all of our operations with regards to OpenGL code happen as soon as possible. Because if we don't set up the context very, very quickly, you'll end up with the problem of trying to execute some OpenGL code. You might have loaded the function pointers from the library, but when it tries to write to something in memory, that doesn't exist. The minor problem with OpenGL contexts is that they are not universal across all platforms. This is mostly because different windowing APIs, so Wayland, X11, the Windows API, and the macOS API, and even stuff on Android and iOS as well, they all have different parts of the context that they will use and they will not use, and they'll be laid out differently in memory, loaded from different locations, so on and so forth. So for a lot of those circumstances, you'll need to make sure that you're loading the appropriate context from normally the software provider. In our case, we're focusing on Windows, so we are dealing with Windows GL or WGL. Again, without further ado, let's hop straight into that. Okay, so under the Windows platform, because this is going to be our Windows specific implementation, we're going to go here and we're going to create a GLManagerWindows.h. And within this file, we're going to have a couple of things. The first thing, of course, pragma once, include our type defs. And then we're going to want to, once again, check if we're on platform Windows. And then from here, we're going to want a couple of things. First thing being our vector library. And we're going to want to get Win32 lean and mean and include the Windows header as well. Sorry, we're not going to want to include our vector library. We're going to instead want to include our error list. You can include the error macros. You probably won't need all of them though. Next up, we're going to want to create, and from here, it's relatively simple. We'll want to create our class, so class GLManagerWindows. It's not going to inherit from anything because there is nothing that we can inherit it from. And within here, we're going to just put some information in here and some private stuff that the class is going to need. So as follows, we have, that should be like that. We have our struct. So we have a struct GL window. This will effectively act very similar to our Windows struct in our display manager. They'll be sort of the same thing, but with different bits of context. So the GL window will contain the Windows ID. It'll also contain the display ID. The HDC, the HWind, and the HDLRC are all very similar things. So the HDC refers to the device context. That is the physical graphics card that you'll be using to render this. That can be integrated, it can be discrete. As long as it supports OpenGL, you should be fine with using that. We also have the HWind. This just refers to Windows internal window. And the HDLRC is our OpenGL context that we have created. We also keep hold of a couple of versions. So we have the version major, minor, and patch, which are all initialized to be 0 upon launch. We also have a pointer to an active window, and that is currently set to null pointer. And we also have a Boolean checking if we are using vsync or not. The reason that we're checking for vsync here is because one of the functions that we'll be loading from the OpenGL library is whether we're using vsync or not. And Therefore, we'll want to make sure that it has a way to be toggled within here rather than being toggled outside of our code, since all of our OpenGL management that isn't strictly rendering stuff is held here. Next up, we have all of our public functions, and these are the ones that are going to be called from wherever this class is housed. And when that is correct, they are as follows. So we have creating and destroying windows, getting the active window, setting the active window, releasing the active window, checking if we're using vsync, setting whether we should use vsync, initializing, finalizing, swapping the buffers, and resizing the viewport. And of course, our class constructor and destructor, which at the moment do nothing. And in fact, I believe this can also do that. Now with all this out of the way and our wonderful GLManager's functions all laid out for us in code, we can go and write the source file for this recording. So under here, we're going to create GLManagerWindows.c++. And within here, we're going to again include our header file, so GLManagerWindows.h. We're going to check if we're on platform Windows. And then we're going to want to include a couple of things from the rest of our engine. First one we're going to want is we're going to want to include our OS. We're also going to include our display manager. And we're also going to want to include from our third-party folder, at long last, we're going to want glad as well. Actually, do we want glad? I could be completely wrong about a lot of this. Now, before we can go and write all of our code for this, there are a couple things that aren't included in the headers that we've included so far that we still need for this application. And we need to go and create those defines ourselves. So I'm going to paste these in right here. And they are as follows. The first lot is a bunch of definitions. These are different context attributes that we need to have hold of somewhere in our code because they don't normally appear in the application. And we also have a couple of function pointers that we describe here. So we have for creating context attributes, we have the get extension string attributes. We also have the swap interval as well. And that there shouldn't need to say int interval, that can just be an int. Now within here, we have our own definitions of these. So we have create context attributes, create get extension string, and swap interval. And now next up, the functions that we need to write. So the first one is going to be our create context. So all right, I'll just go ahead and paste it in here and I'll explain through the function as we go. So starting up here is a bit of an unhelpful bit. This is setting up the pixel formats. We'll get onto this function in a moment, so I can explain that later. But all you need to know for now is that you do need to create the pixel format so that later parts of this code can work. The next thing that we're going to do is we're going to quite simply create a context using the current device context, which is passed through from the original. So you can imagine that when we originally create our window, we'll get the device context and that'll be applied to the window as is. Also here we use GL window and we use this and. So this is not necessarily a pointer, but it still is modifying effectively the same window that you'll pass into the function. And if the GL context that is created is null, then we'll print an error and return error can't create. We'll also do a similar thing here, where if we can't make the current OpenGL context current, then we'll simply return in a moment. Another thing to note is that what we're trying to effectively set up here is the way of initially creating contexts. So using WGL create context and setting it to current. While that works on a very basic level, we want to be able to modify some attributes relating to our context. And by that, we normally mean that we want to load some different things. So here, as you'll see, we have an array of integers and these define some attributes that we want to set. Now here we have our WGL context major. So this simply refers to the major version of OpenGL we want to use. And a similar thing here with the minor version. This will simply refer to this. And the way I have it currently set up is that we set it to a 4.6 context, so the very latest version of OpenGL. But as I've written here in the comment, eventually we should probably fall back to using 3.3 at some point. Then we ask for what kind of profile we want to set up. So we set up a core profile. And then the context flags, we also want to set forward compatible, which means that it is only it uses all the functionality that exists from modern OpenGL, which is 3.3, but can also use the stuff that exists in older versions because you need a lot of that. So here we call to WGL get proc address. This simply will look for this function within the list of functions that exist within the WGL DLL file, so the OpenGL32 on Windows. And if it does find this function, then we can move on. But otherwise, if it is null pointer, then we want to delete our current context, set it to null pointer, and say that we cannot create the function. Then we want to create another GL context. So we want to create a context that is using the information that we have specified here, passing the current device context, the current OpenGL context that we set up earlier, and the current attributes. And if that is null pointer, sorry, that should probably be, yeah, this should be equivalent to null pointer rather than being a not there. For some reason I'm inconsistent with that. And then we'll delete the context, set it to null pointer, and say we can't create if we could not find it. We also go ahead and load the extension strings. And if that's null, then we delete the context and again. As I might have mentioned earlier, we don't necessarily need the extension string at the moment, but it is a nice thing to have. And we may want it later down the line if we're trying to specify specific features that exist on our OpenGL version. Then we load the WGL swap interval ext. What this will do is it will look for if this function exists, and if we can call it, this will allow us to toggle between using vsync and not using vsync. And from there, we've obtained all the function pointers that we want to load from the context. So we want to set the current device context to null so that there is none currently applied. We would then want to delete that context. Then we set our current Windows context to the new context, and then we make that one current. And if we couldn't do that, then we can't attach the new OpenGL context. We delete it, set it to null, say we can't create. And otherwise, we return OK if all has succeeded. Next function up is configuring our pixel format, and I will just paste this in here and explain it once more. So the pixel format descriptor is a struct, and it will request various bits of information. So the first thing it'll normally ask for is the size of the struct, which we pass in. Then we specify some flags that we want. So we want to be able to draw to the window. We want it to support OpenGL, and we also want double buffer. This we'll come back to in a moment. We also specify what kind of frame buffer we're dealing with. So in this case, we're looking at a RGBA frame buffer. We could simply load an RGB frame buffer rather than RGBA, but the alpha allows us to do a little bit more with transparency with individual pixels. We then say the color depth, so the number of bits in the per color, which specifies the variety of colors that we can have. So 32 specifies effectively 8 bits for red, green, blue, and alpha, which gives us a degree of precision that can be high quality. We then have a bunch of stuff that for now we are ignoring. So these are just all set to 0 by default. I don't believe they do anything significant at the moment. We then have the number of bits in the depth buffer. So the depth buffer is effectively OpenGL's way of knowing how close 2 points are, because when you're taking a 3D scene and translating it to 2D device coordinates, you'll need to know if one pixel is in front of or behind the other based on its Z coordinate, and the precision of how close you can have these before they start Z fighting, which is where you get conflicting textures that exist at the same level and are trying to render on top of one another. This specifies how big that buffer is and therefore how precise it is. And I honestly have no idea what the stencil buffer does at the moment, but I know that you need 8 bits in it at the moment. And then we set the rest of these flags aside from this one to PFD main plane, which just, again, summarizes to 0, but we keep it as that because we want to be effectively drawing to the main area of the window. And we set everything else to 0, as I said. The choosepixelFormat function will take the current device context and it will look through with this specific struct here, and it will basically look to see if there's any pixel format that they can find that aligns with the one that we have specified here. Since there will be a great many different pixel formats per window, because there are multiple ways of specifying this information and specifying what we need from it. And if it couldn't find a pixel format that was valid, so it normally returns 0, we therefore say, okay, well, we couldn't find a valid pixel format, so we're going to return -1. And otherwise, if it did find the pixel format, then we will call to set pixel format, which again takes the device context, takes our chosen pixel format, and passes in the pixel format descriptor that we specified. Now, all of this is looking wonderful so far, but how do we create a window? And that is what the next function will be. So at the moment, creating a window is relatively simple. You need to pass in the hwind from somewhere else in the application, and we also want the h instance for some reason, and it doesn't seem to be used at the moment. So you don't technically need it, but I'll keep this here because we may want it down the line. So the first thing that you'll do is you'll want to get the device context. So what we call is we get DC from the hwind. If it couldn't get the device context, then we return -1 because we can't create a window. And if you're wondering where you get the DC, if you remember way back in DisplayManagerWindows, if we go here, you'll see that we call to CS own DC. And what that means is that the window that we are creating will own its own device context, or it will have a device context, and therefore we can use this function here to find our device context from there. And then we want to just create a window data struct. So we just allocate one. We set its ID to 0 because, again, there is only one window being used at the moment. We set its hwind to equal the one that we passed through. We set the device context to the one that we just got. And then we call to the pixel format to configure it to see if we get one. And then we call to create context on our window data struct to see if we can create one for the current window. If that isn't the case, then we return -1. And otherwise, we set the active window to equal the current window data. Now, I'm quite interested why I have called configure pixel format here when we already call configure pixel format when we're creating the window. So I think for the meantime, I can get rid of this. Of course, if this causes our code to violently throw up, we will remember that we did that and we will fix that later. And as you may be used to, there is always a destroy window function as well. So what we do here is we check if the active window is equivalent to the ID. And if that is the true case, then we set it to null pointer. And what we should also do is we should also call to our static allocator to free our active window from the size of a GL window. And that way that saves us from worrying about allocations overflowing because we're not actually deleting the memory, we're just saying that it's null now. Next up is a whole bunch of functions relating to the active window. So we have get, set, and release. Get simply returns the ID of the currently active window. Setting active window takes an ID, so it assumes that you already know the ID. And if that ID is invalid, then we return. Otherwise, we get the active window. We then make the context that is that active window current. Then we return. So it doesn't actually use anything with the ID because there is only one window. So we just make that one current if we can. And release the active Windows simply refers to the act of seeing if the window exists, and if it does exist, get rid of it, or we just make its context not current. And realistically, what we should be doing here is calling to destroy window and calling on the active Windows ID, just to make sure that it is appropriately destroyed. Next up is our vsync functions. So here, what we'll be doing is we'll be first off checking if vsync is being used. So that will be a true or false. We do also want to do a check. We want to check if the function doesn't exist and if the disable option has been specified. And if neither of them are true, then we can't disable vsync as the extension isn't present. So it just doesn't exist. And otherwise, we will call to change the swap interval. If this specifies true, then it will change the swap interval to 1, which will normally be whatever your monitor's refresh rate is. And if it is set to 0, then it will simply try to render as many frames as it can during a time, which often gives us faster speed, but lower stability and can cause things like screen tearing, as you may be used to. And that's pretty much all of the utility functions / actually setting data. The next thing that we need to do is we need to add our initialize, finalize, and other functions. So the first one is our initialize. And what we're going to do here is we're going to call to glad, and we're going to try and load all of the glad functions in because they are needed very quickly. Ideally, we would set this in the rendering server, but we don't have a rendering server yet. So we're setting it here for now because there's a couple of simple functions that we want to set up first. But that's the only problem that can really go here. If glad can't be loaded, then we say that it couldn't be, and then we return error can't create. Otherwise, everything was okay. Then we have the next 3 functions, which I will do my best to explain. We have finalize, which will just release the active window, set all the versions to 0. It doesn't really need to do this, so we can probably get rid of that for now, because that won't mess anything up. We also have swap buffers, and now I get to explain what swap buffers mean. So normally when we're doing OpenGL writing, there are 2 frame buffers. There is the frame buffer that is being presented, i.e. the one that's being on your screen, and the one that is being written to. That's normally where all of your OpenGL functions go. Originally, when people were writing rendering APIs, there was only one frame buffer. That was the one that was immediately on the screen. Every operation would write to that, and that meant that you didn't have to worry about swapping or whatever. But that would also bring up problems because it could cause flickering, it would cause, visual tearing, and lots of problems could arise because there was only one buffer. So that led to the creation of 2 buffers. The first one, which is the presentable buffer, is usually the one that gets shown at the end of the frame. So every action that is input into an engine will normally get processed, and then it will wait until the end of the frame to present that. And these 2 buffers will go in and out of being used. So normally what happens is the buffer is finished presenting. They are swapped, so the previously active buffer is now being presented. And it will go undergo its right operations. It will normally be cleared. You'll start adding, you'll populate it with items that you want to render, add textures, images, other frame buffers, whatever. And once that's done being rendered, it then swaps. So that frame buffer will then be shown to the screen, and the previous one will then be cleared and rewritten to. And that way it kind of keeps a fluidity going. So you don't have worries about flickering. And there are 3 different ones that are being, and there are 2 different frame buffers that are being written to. Now, some applications, such as Vulkan, do support triple buffering, where there are 3 frame buffers to write to rather than the usual 2. But for now, we'll just be sticking to 2 because for the most part, we will be using OpenGL only at the moment, so we won't be worrying about anything Vulkan specific for a while. But all in all, that is everything in our GL Manager now written up. And we can probably start creating some windows and start drawing things. However, we do need to do a couple things first. And that is, of course, get this hooked up into our display manager and then start worrying about actually getting this to work. So in our DisplayManagerWindows, we're going to scroll to the top, and just before every other include, we're going to hit a couple keys here. We're going to include, and we're going to want to get to that GLManagerWindows.h. From here, we're then going to go and create a GLManagerWindows, GLManagerWindows. And this will be effectively our singleton that will manage all of our individual functions. So within the Display Manager, the first thing we need to do is we need to scroll to the bottom. And down here, we need to create our OpenGL Manager because there's a couple of things it needs to do first. So first, we're going to call to GLManagerWindows equals a new GLManagerWindows. Then we're going to have a couple other things go on here. And all of those is the initialization. And then if it fails, then we want to print a message, and that will usually be in the form of actually getting the error string that it's relating to. And that will return prematurely from our constructor. Hopefully you don't get any errors here, because otherwise this is a pretty bad place to return from, because this is, of course, the Display Manager. And the other thing that you need to do here is, if you can guess from the Display Manager video, we also need to delete this GLManagerWindows. It's the only thing really that we currently have that we actually need to get rid of. So we do that as so. Now, all the way up at the top here with our create window, we're going to want to do a couple of things. Right at the bottom here, just before we set the window to the new window and return the ID, we're going to check if we can create a GL window using what we currently have. So if GLManagerWindows, so of course, if the GL Manager does actually exist at this point, then we're going to want to get its ID from creating the window. You'll want to pass in the new window and its hwind, and you want to also pass in our own h instance. And if the ID is equivalent to a uint 8 -1, you have to do a typecast here because, of course, -1 doesn't exist in unsigned integers. This wraps around 255. Then we want to actually get rid of the GLManagerWindows entirely. And then we'll call here to say that the GL window was unable to be created. And then we'll return error can't create. And otherwise, if that doesn't happen, then we'll just want to set the active window to whatever we pass through. So set active window ID. And we'll want to set our new Windows ID to the current ID, which should be the same up to this point because, again, we are manually setting both of them to 0. Then within our destroy window function, we're also going to want to do something very similar for destroying the window on the GL side. So if GLManagerWindows, destroy window, passing in the ID. Next up is our swap buffers then, and as you can imagine, this is where the majority of the DisplayManagerWindows works. So we call to GLManagerWindows to see if it exists, and then we call to its swap buffers. So again, as it can swap the two frame buffers around. And that is simply the existence of that function explained. Then we have another interesting event. So here within our window procedure, we do need to add another event, and that is one for case WM size. This is the one that is called whenever the window is needing to be resized in some manner. So we call to break at the end, and we want to get a couple of things. The first thing is we want to get the width of the window, which is contained in the lparam. So we call to low-word lparam, and we get the uint32 for the height from high-word lparam, which should be an equals there, not a whatever that was. And then if the GL Manager does exist, because again, changing depending on the size of the viewport will be something that we depend on in Vulkan as well. The GLManagerWindows, if it exists, then we want to call to it to resize the viewports based on the width and the height. And then from there, we will break out of the function. And from there, we're more or less done. Now with all of this out of the way, it's time to go into our main and start making more of this work. So first things first is we're going to want to get another include. And this is just for testing purposes. We're going to include from third party glad.h. And we're going to set a clear color for our screen. And this is just to show that the rendering is actually working and that OpenGL is actually doing things. First thing is we're going to call to GL clear color. And this is going to set a color value that we're going to clear the screen to. And that is 0.2, 0.2, 0.2, 1.0. Always make sure that this here is your alpha value and that is set to 1. Then we're just going to call to GL clear on the GL color buffer bit. And what this will do is it will make our screen a dark gray color to clear to. Then what we're going to do is we're going to call to our display manager to get the singleton and call to swap buffers. And that is about everything that we need to do for now. So from here, we should be able to hit Control-Shift-B and build. And here we get a couple of errors because the GL versions aren't used yet. We will be eventually updating these, but for now you can just hit Control/ and comment these out. They will be used at some other points during here. When we actually have the ability to set those, it's a little bit later down the line. So from here, we'll try and build again, and we'll see that it builds successfully. Then we're going to hit F5, and it should run as intended. Okay, a bit of a problem here. So the main problem that you might have just noticed is that Glad couldn't load itself. And there's a reason behind that. So when Glad is normally loading the functions, and the way most OpenGL loaders load functions, is they need an OpenGL context to be created so that they can extract all of the other OpenGL functions from the file. If there isn't an OpenGL context created, then it can't load the successful function pointers. It will then fail. It will say it can't load, and we'll get a whole bunch of problems. So we do actually need to do some changes somewhere, and I believe it is a relatively simple fix for the moment. So while it is going to seem counterintuitive, we are actually going to move the create window function, and we are going to pass it here instead of down here. This should probably not be this way round. It should almost always be that the GL Manager is created first. So actually, I'll swap it around again so that we create the GL Manager, then we create the window, then we initialize. This, again, really shouldn't be this way, but for the moment, until we actually get our rendering server set up, this is how we're going to have to do it for the moment. So again, we'll hit Control-Shift-B to compile, and hopefully this way around it works. And there we go, it did work. So now, as you'll see, nothing interesting is happening, but our window has gone from being completely white to now being completely gray. If we were to use any of our OpenGL functions to start loading things into the scene, you would start to see that things can now be rendered. And of course, this is a pretty big step because we're just a few OpenGL functions away from drawing our first triangle. So I'll close this window and you'll see that we get no errors on the exiting. So that is all good. And we are pretty much done on this one. So again, thank you very much for watching. Hopefully speaking, we should be on our way to actually getting the first sort of step in this series done, and we can move on to some slightly more interesting things in the future. However, we also have to do this exact same process over on Linux. So that will be the process of the next video. That will be where we do the same thing for X11. Then from there, you'll be very glad to know that we shall be moving on from the context creation side of things to rendering our triangle and actually getting into the nitty-gritty of using OpenGL. So again, thank you very much for watching, and I'll see you in the next video. Goodbye.